Chapter 11, Areas of Polygons. Today we're going to cover Section 11.6, Arc lengths and areas of sectors. Objectives for today will be to know and use the formulas for arc lengths and the areas of sectors of a circle. The two things I think of would be the arc length is just part of the circumference of a circle. So when you're looking at this, you're really just finding what's the circumference of a circle and then what part of that do we have? Well, I know a complete circle is 360 degrees, so whatever part of the circle we have is just the central angle or the arc measurement divided by 360. So that would tell you, do you have a third of a circle, a fourth of a circle, a tenth of a circle, and so on. So arc length is just find circumference and multiply it by what fraction of the circle you have. The sector areas is sort of the same type of thing. If you know how to get the area of a complete circle, pi r squared, well, when I look at the sector area, I'm just looking for what fraction of the circle do I have? Is it a half, a third, a fourth, and so on? And to get what fraction of the circle, just take the central angle and divide by 360, tells you how much of the circle you're actually dealing with. So here's our first problem. Sector XOY is described by giving the measurement of angle XOY and the radius of circle O. Make a sketch and find the length of arc XY and the area of sector XOY. So making myself some pictures here is going to be really helpful. So here's going to be my first problem. And if I start to fill in, they're talking about circle O, so I know the center is O. They're talking about sector XOY. So the first problem here is a 90-degree angle. So this angle XOY is going to be for a 90-degree angle. And they want me to find what's the arc length and how big is the area of the sector. So first thing I'm thinking of is I need to find what's that arc length. And I know it's a 90-degree angle, and I also know that the radius is 8. So if I'm looking for the arc length, I know that I start by finding the circumference of the circle, and the circumference of the circle is 2 pi times the radius, which in this case is 8. Well, that's a whole circle. How much of a circle do I have here? Well, if I look, I can see that it's a quarter of a circle. If you don't notice that, you realize you just multiply by 90 degrees out of 360 degrees. And I know that 90 out of 360 is going to reduce to 1/4. And now I'm just multiplying a quarter times what the circumference would have been. Well, I also notice that I can reduce here. 4 goes into 8 twice. So if I multiply what's left, I have 2 times 2 times a pi, which is 4 pi. Now let's find the area of the sector. So I'm really going to look at my diagram and think, what's the area of this piece right here? Well, I know how to find the area of an entire circle. And the entire circle is pi times the radius squared. But I'm not finding a whole circle. I'm only finding the circle that's 90 degrees out of 360, which right up above we realize reduced to 1/4. And here's the problem I need to deal with. So if I do this, I get pi. 8 squared is 64. I can reduce, 4 goes into 64 16 times. And if I multiply this, I end up getting 16 pi. Going on to my second one, I'm going to draw myself a new picture. Well, the second one, they tell me that this angle is going to be 120 degrees. So I don't need to be exact, but I want to look relatively close. So if I know where 90 is, this is going to be a little bit bigger. So this is going to be a 120 degree angle. And here's XOY. And I just start to go through and do the same information. I know my radius is 6 square roots of 2. And if I want to find my arc length and my area, the first thing I'm going to do is my arc length. So it's circumference, so that's 2 times pi times my radius. And I'm going to multiply this by how much of the circle do I actually have? Well, I have 120 degrees out of 360 degrees. And now let's start to reduce where I can. I know that between 120 and 360, that just reduces to 1/3. I can reduce 3 goes into 6 twice. And if I multiply what's left, I get 2 times 2 is 4. There's a pi, and there's a square root of 2. Going to the area. And I know if I try to find the area of this sector, I start by just finding what's the area of an entire circle. So the area of an entire circle would be pi times radius squared. That's going to be pi times 6 square roots of 2 squared. But now I don't have a whole circle, I only have 120 degrees out of 360 degrees, which from the problem right above we know is reduced to 1/3. And now simplifying this. So I know I'm going to get pi. If I square 6, I get 36. If I square the square root of 2, I get a 2, and I still have times 1/3. 3 can go into 36 12 times. And if I multiply across, I get 12 times 2 is 24, and I still have the pi. On to our third shape. So my third circle, I still have O as the center. And now I have a 200-degree angle. So in this case, I'm really looking for how big is that, and this angle over here is 200 degrees, and my radius is 0.3. Finding the arc length. I know that the total circumference is 2 times pi times my radius, which is 0.3. But I don't have the whole circle, I only have 200 degrees out of the 360 degrees. So let's start to reduce. I noticed that the 200 and 360 I can reduce by 10, then I can reduce by 4 and get 5/9. I can reduce between the 0.3 and 9, which will give me a 0.1 and a 3. So looking up in the top, I have 2 times 5, which is 10. 10 times 0.1 is just 1. So I get a pi in the numerator, and the denominator is 3. So I get pi over 3. Let's find the area. So I know the area equals pi times radius squared. And I know that my radius is 0.3. And I don't have a whole circle, I still have 200 degrees out of 360 degrees. And if I start to simplify, I know that I have my pi. 0.3 squared is 0.09. And I can reduce, and let's see if I reduce again, I can cancel out the zeros between 20 and 36. 4 goes in here 5 times and 9 times. So I'm going to end up with 5/9. And from here I can reduce. I notice that the 9 will reduce with the 0.09 and give me 0.01. So now I have 0.01 times 5, which is 0.05, and then I still have the pi. So final area, 0.05 pi. Finding the area for this one. Well, I noticed that it's the little blue shape. So what my sort of idea would be is if I could get the area of the sector, subtract off the area of the triangle, the piece that's going to be left is the blue shaded in region that I want. So how can we get the area of the sector and of the triangle? So area of, and I'm just going to draw a little symbol of like the sector piece. So that's going to be for a circle. So I know the area of a circle is pi times the radius squared, and my radius is 2, times the portion of the circle that I have, and I see a 90-degree angle in the middle. So I know I have 90 degrees out of 360 degrees. I know that 2 squared is 4. And now I start to reduce. Well, I know that I can reduce by 10. 9 goes into 36 4 times, and the 4's cancel each other out. So my area is going to be pi. Now let's figure out what the area is for the triangle. So for the triangle, I know the formula is 1/2 base times height. Well, the base in the triangle is the radius as well, which is 2. And the height is the radius, which is 2. So I get half of 2 times 2, which is going to be 2. So final answer, I'm going to even look at my little pictures up here, would be the area of the sector, which was pi, minus the area of the triangle, which was 2, and my units are centimeters squared. Going to number 5. This one, there's a couple different ways I can look at this. I could either do an entire circle minus the little piece that I don't want, or in this case, I'm going to think of this as 2 separate shapes. One of the shapes I'm going to think of is as this much of the circle right here. So it's sort of like 3/4 of a circle. And then I'm going to think of the second shape as the triangular shape. So I'm going to split it up into those 2 shapes and add them together. And I think I'm just going to call it area 1 and area 2. So if I look at the area for shape 1, I can look and see that it's 3/4 of a circle. So the formula is pi times the radius squared, so that's going to be an 8 squared, which I'm going to square right away and put down 64, times, I know it's 3/4 of a circle, and if I reduce, I know 4 goes into 64 16 times, and if I multiply what's left, I get 3 times 16, which is 48 pi. Now I got to figure out the area of the triangular region. And I know that a triangle is 1/2 base times height. And the base is the radius, which is 8, and the height is also the radius, which is 8. And I know I can reduce. 2 goes into 8 4 times, and 4 times 8 is 32. In this case, I'm adding the areas together to get my shape. So my final answer will be taking the 48 pi for the sector and adding on the area of the triangle, which is 32. And the units are centimeters squared.